Welcome back. I'm here on behalf of Forge College. Last time, we wrapped up our look at load balancing experiments, figuring out how to handle network traffic. Today, we're shifting gears to something just as crucial. We are tackling advanced Hardhat configuration and integration. We're going to build the setup that drives your capstone project workflow. Have you ever wondered why a mass-produced candy bar tastes exactly the same whether you buy it in New York or Tokyo, but your homemade chocolate chip cookies come out a little differently every single time you bake them? That messy kitchen is like your laptop when you're writing code locally. Sure, your smart contract might compile successfully on your personal machine, but it's often relying on a pinch of luck and a bunch of hidden local settings you might not even realize are there. Now compare that to a continuous integration, or CI pipeline. A CI pipeline is like a strict, fully automated robotic bakery. It demands absolute precision, exact measurements, and zero guesswork. If you hand your messy, unstandardized local code to this automated robot, the system won't know how to process it. The build will crash. To get the exact same results every time, we have to write some incredibly strict configuration recipes. Let's look at how we actually program this robotic bakery. The very first rule of automation is simple: remove all assumptions. We do this through a process called pinning inputs. Instead of telling your tools to just use whatever default settings happen to be available, you lock down the exact version of every single tool you need. Looking at this schematic, we see our robotic scanner meticulously checking its materials. We do the exact same thing with our code by specifying the exact Solidity compiler version we want, like version 0.8.20, rather than just asking the system to grab whatever it finds. When you lock down every input like this, you achieve what's called a deterministic build. Just as our machine stamps out identical gears, this process ensures that the exact same inputs will produce the exact same byte-for-byte output, no matter which computer is doing the work. This ensures that when you work with a team, the code behaves exactly the same way for everyone, every single time. Once our inputs are pinned, we move to the next phase of the pipeline, environment management. We control the environment using handy little automation scripts called hooks. Here we see our automated workstation going through a setup cycle. In our code, these are called pre-test hooks. Think of them like a robotic arm washing and staging the mixing bowls before any baking begins. They handle the preparation, like setting up temporary test data. And right after the baking is done, we run our post-test hooks. As the robotic arm sweeps the workspace clean, these scripts guarantee that temporary files are deleted. They make sure no leftover data can leak into the next process. By keeping each test environment isolated and clean, we prevent a chain reaction where a mistake in one test accidentally ruins the results of the next one. Now, even the best bakery needs to keep its recipes safe. Our automation bots require sensitive information, like private API keys, to talk to the blockchain. It's a massive security risk if these values get printed into your public logs for anyone to read. It's like having a secure vault door, but leaving the combination written on a sticky note for everyone to see. To keep things secure, we use environment variables. This is a method for feeding those secrets directly to the automation script without ever writing them down in the code itself. We configure Hardhat to pull these variables straight into its active memory. The automated tasks execute perfectly behind the scenes, while your visible logs remain totally clean and secure. Proper secret handling is a requirement. It gives you the power of full automation without ever leaving your smart contracts vulnerable to outside access. We've built securely, and now we reach the final stage of the process, generating proof of exactly what code was built and tested. In Hardhat, these proof files are called artifacts. Watch as our automated checklist takes off each requirement. These files act like a meticulous health inspector's receipt. They record the exact settings used to create the code, providing a clear history of how it was made. We also configure Hardhat to do something called artifact pruning. This just means it automatically deletes old, outdated files so that our system stays fast and doesn't get cluttered with digital trash. This creates a verifiable record of our work. Having this paper trail allows us to audit exactly what happened, giving us the confidence we need to launch our code on the Ethereum mainnet. Let's look at how all these pieces fit together. This entire configuration forms the engine of your capstone project workflow. By combining exact inputs, automated hooks, and tight secret management, we take a messy, unpredictable local draft and turn it into a reliable, repeatable machine. Mastering this kind of configuration helps remove human error from your development process. And with that, we officially wrap up the Hardhat Fundamentals course. You are now ready to take these skills and integrate them into a multi-framework Ethereum dev stack. This video was created by Forge College. To dive deeper into these topics and continue your journey in Web3 development, visit us at forge.college. Happy coding, and we'll see you in the next build.